Hi, my name is Glenn Morris, and the instrument that I'm going to go over are radiometers. Just some definitions to get out of the way. A radiometer. A radiometer is an instrument that measures the intensity of the surrounding radiation. So it picks up the wavelengths or the heat or just anything with its camera. You'll see a picture of it later. The black body. An item or surface that absorbs all electromagnetic radiation regardless of frequency and angle. So yes, and this is what's gonna be used to fluctuate the temperature, what the radiation, or not the radiation, the radiometers are gonna measure at. Celsius, a scale of temperature where water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. Most meteorological things are based around the Celsius scale, not really the Fahrenheit. There's some with the Kelvin, but most of it's Celsius. And for uncertainty, it's about an approximation, where the actual answer, for example, is 45 degrees, and it reads 43. The uncertainty is 2 degrees. Honora is a French company that takes radiometers and makes other technology. Honora is going to be brought up here later in a little bit. Spoilers, just letting you know. These were all the types of radiometers that were used in this project. It would take me hours upon hours to go over all of the radiometers. Plus, these aren't all the radiometers that weren't even used for this project. Like for example, like the sister radiometer or the DMI, the amber radiometer. You could see some of the detectors, what detectors it's used, or its field of view right here. But the main radiometer that I am gonna go over, spoil, is the Honora radiometer. The Honora radiometer has a 95-degree target radiometer. Viewing target distance is at 2 meters and operates at the 9.6 to 11.5 nanometer spectral band. For this project, they sent 4 different types of Honora radiometers. The first 3 were the Hytronics KT 1985s, and the 4th one wasn't even a radiometer. It was a BOMEM MR34SC spectrodiometer, and it's gonna mess up a lot of things you're gonna see here in a little bit. This one right here, the top one is the Hytronics KT 1985 is the top one right here, and the bottom one is the BOMEM MR 304 SC. The black body that was used for this project was an ammonia heat pipe. It was controlled by a cylindrical heat exchanger and the heat transfer fluid in helical grooves, which is like right here, and the platinum resistance thermometer, which is right here, which helps regulate the temperature and keep it consistent. You can see the heat exchange assemblies right here where the ammonia would be. The pipe is right here. You can see the liquid duct that's going out and the liquid that's going back in, because you need fresh stuff to keep a good temperature going. The data that was collected from this black body with the radiometers was kind of interesting. So for the negative 30-degree temp plot, the Honora radiometers were scattered. So the Honora radiometers are the blue diamond, the dark blue diamond one, kind of in the middle. And this is the highest really the uncertainty is, besides the third one. The third one is around 0. The first two are around 700 to 850 MK difference, or the uncertainty is that. And the fourth one's an outlier. It has about 1700 MK difference. For the negative 15 degree plot, the first three are getting more consistent. The first two are near zero, not quite. There would probably be around like a 100 or something. This third one would, yeah, probably be around like a 250. It's in between the 500 and zero. The last one is still an outlier. You're gonna find a trend with this, with the fourth one. It's always gonna be an outlier for the most part. It's around 1400 MK difference, so it's going down in uncertainty, but it's still an outlier nonetheless. For the 0 degree plot, the first two are near or at zero uncertainty, so they're very close to zero and good readings on them. The third one's around 200 MK difference, so it's a little up there. And the fourth one, surprise, surprise, still an outlier. It's around 500 MK difference, so again, it's still going down as the temperature is going up, so that is still a good sign. For the 10 degree plot, and this is all in Celsius, just letting you know, just all the temperatures are in Celsius. That's why it was in the definitions. I forgot to point that out. The first two did not move practically at all. The last two uncertainties are dropping. The last one's still an outlier and around 400 MK difference, so it moved a little. And for the 20 degree plot, the first one actually went up just a little, but still kind of weird how they went up a little. The third radiometer is the lowest uncertainty, so it's like around a little under 100, where the rest are like at 100 or something like that. And the fourth dropped its uncertainty, but is still an outlier. It's like right under 250 degrees still. The 30 degree plot, fourth one did not move, still an outlier. The second and third degree have zero uncertainty, the diamond's touching the 0 degree mark. And the first one's just a little above it. It's about like at 100 degree MK difference, which is also the uncertainty. The 45 degree plot, finally all four of them are very consistent with each other. The third one is the closest to zero uncertainty. The first two uncertainty risen up a little, according to the graph anyways, but it's still, the MK difference is still around 100, so still very good readings for all four of them now. The data analysis that I got from all those plots and graphs for the Honora radiometers for the cold temperatures had a decent uncertainty compared to the rest, but was the most consistent, and it was the most consistent if you count out the fourth radiometer, because the fourth radiometer messed up everything when it comes to that. As the temperature got warmer, it didn't drop to the negative uncertainty and stayed very close to zero uncertainty or risen a little. So some of the radiometers went to the negative, so it went past zero, so it, the temperature read less than it actually was. And the fourth radiometer was a spectroradiometer and was an outlier until the 45th degree plot, which it is what it is. That's how plots go sometimes. They're going to be outliers, and data's going to have some outliers. That's just how it is, including when it's a different instrument that's not a radiometer. For my conclusion, radiometers have an internal black body were far more superior with uncertainties, and most radiometers had a bigger uncertainty when the temperature was very cold. So when the temperatures were super cold, most of the radiometers uncertainties were very big. But if it had an internal black body, which it has, it can, I guess, warm up by itself, I think that's what it is. I don't know exactly. It had better readings. So like the Honora one had an internal black body. That's why it didn't drop below 100 or was around zero. At least one of them was all the time. The Honora radiometers are better in warmer conditions and was one of the most consistent radiometers. At least one of them was always around zero uncertainty. So like I said, one of them was doing very good. And advancing science, this data will help scientists know what radiometer to use in situations or what weather help scientists see how radiometers work in general, and help scientists know which radiometers are better in general. So like if you're like weirdly in the Arctic or tropics, what radiometer would be best in those situations? And these are my references. Thank you.